between stars is cutting through our solar system. Scientists call it 3I-ATLAS. But from the first measurements, one thing became clear. This is not behaving like any comet we've ever observed. Its chemistry is strange. Its light signature breaks the rules, and its tail is pointing the wrong direction. With every new observation, the mystery only grows. So, what exactly is 3I-ATLAS? 3I-ATLAS was discovered on July 1st by the Atlas survey in Chile. It earned the 3I designation because it's only the third confirmed interstellar object humanity has ever seen. How do we know it came from outside the solar system? Because its velocity and trajectory are impossible for anything born here. Objects from the Oort cloud, the huge icy sphere surrounding our solar system, enter with extremely low initial speeds. 3I-ATLAS doesn't match that profile at all. Its path is unbound, hyperbolic, and moving far too fast to be local. This thing came from deep space, from a star system we may never identify. Early infrared and spectroscopic readings revealed something astonishing. 3I-ATLAS is ejecting nickel and iron at a rate scientists describe as exceptional. Not just a little, but in quantities never recorded from any comet in our solar system. Metals like these usually remain locked deep inside rocky bodies. To see them venting into space so early, while the object is still far from the sun, suggests an internal structure unlike anything we've encountered. Combined with an unusual CO2 to H2O ratio, the chemistry of 3I-ATLAS refuses to fit any known comet model. Some researchers have even pointed out that the ratios resemble engineered exhaust, but these interpretations remain speculative and controversial. Still, science can't ignore anomalies forever. One of the strangest findings came from polarization measurements, the way light scatters after bouncing off the object. 3I-ATLAS produces patterns described in papers as unprecedented, not consistent with asteroids or comets' first ever observed behavior. Polarization reveals surface texture, grain size, and composition. And this object's surface seems to be made of materials or structures we've never encountered. If 3I-ATLAS is natural, it may represent a class of objects whose properties are unfamiliar because they formed around other stars. If it isn't natural, then we're looking at something far more consequential. Perhaps the biggest surprise came when astronomers detected a tail, but not the usual kind. Instead of pointing away from the sun, like every known comet tail does, this one pointed toward the sun. That shouldn't be possible. Solar wind and radiation pressure normally push dust and gas outward. A tail pointing inward means something unusual is controlling or influencing the flow. Researchers hesitate to draw conclusions, but they agree on one thing. This may be the first time such a phenomenon has ever been observed. 3I-ATLAS doesn't just enter our solar system. It moves almost perfectly along the ecliptic plane, the same plane where planets orbit. For an interstellar visitor, this alignment is statistically rare. But ironically, it may simply reflect detection bias. We're far more likely to notice objects that pass through this thin disk of activity. On its journey, it will pass close to Mars, Jupiter, and Venus, but not Earth. An odd point raised by those who favor more exotic explanations. If this were a guided probe, why wouldn't it target the one planet in the habitable zone? The simplest explanation is still that this path is random, shaped by gravity, not navigation. A minority of researchers argue that the possibility of 3I-ATLAS being technological debris shouldn't be dismissed out of hand. Their argument is probabilistic. If advanced civilizations exist in the galaxy, their probes, failed missions, or fragments could drift between stars for millions of years. 3I-ATLAS could be one such fragment. There is no evidence for this yet, but science cannot eliminate possibilities without sufficient data. Ignoring a genuine artifact would be one of the greatest scientific mistakes in history. But claiming alien technology without proof would be equally damaging. So researchers walk a tightrope, skeptical but alert. Even if 3I-ATLAS turns out to be a purely natural object, it is still groundbreaking. Interstellar objects are samples of other star systems, materials formed under alien conditions. Studying them gives us information we could never obtain otherwise without interstellar travel. 3I-ATLAS is a messenger from another sun, and messengers always carry stories. On October 29th, the object reaches its closest point to the sun. Unfortunately, it will be on the far side of the sun from Earth, making observations extremely challenging. But astronomers are preparing spectra to understand its chemistry light curves, to study rotation, astrometry, to refine its path radio, and infrared monitoring to search for unexpected behavior. Whatever happens at perihelion will be crucial. The increased heat may reveal new gases, cracks, jets, or changes in brightness. It could confirm the comet hypothesis or deepen the mystery. Once 3I-ATLAS swings around the sun, it will accelerate outward, leaving the solar system forever. It may wander the galaxy for billions of years before passing through another star system, another world, another civilization. But the data we gather today will stay with humanity, a record of what travels between stars, a reminder that our solar system is not isolated, but part of a vast, ancient galactic ocean filled with wanderers we are only just beginning to see.